Hi, I'm Ms. Hearn. Let's get started. In this video, we're going to discuss relations and functions. So to get us started, I want to remind you of what an ordered pair is. So here we have an example of an ordered pair. An ordered pair has two coordinates, a first coordinate and a second coordinate. We call the first coordinate the x value, or the input, and the second coordinate, the y value, or the output. And sometimes we represent these ordered pairs in a graph. So for example, the point 4, -7 would be in the fourth quadrant of our xy coordinate system and looks something like this. We might have a whole bunch of points plotted, like the whole set here of 3, 4, 2, 5, -1, 5, 4, -7. We could plot each of those points. Any set of ordered pairs is called a relation because it defines a relationship between a set of x's and a set of y's. So you can also represent a relation as an equation, like this equation here gives a relationship between x and y values. For example, if I were to plug in the x value 2, we would get 3 times 2 is 6 minus 1 is 5. So we have a relationship between the 2 and the 5, the x and the y value. And we can plug in really anything for x. Like for example, we could plug in 2.1 for x. So 3 times 2.1 minus 1 would be 6.3 minus 1, which is 5.3. So we see that we have a relationship between 2.1, the x, and 5.3, the y. And I could go on forever listing out an infinite number of ordered pairs, but instead, since I can't actually have time to list an infinite number of ordered pairs, I give a relationship defined by an equation. Our relations might be a list of ordered pairs, or they might be represented by an equation. So if I said, give me an example of a relation in set notation, you might say, okay, I'm going to have the 0.11 and the 0.22 and the 0.33, and those are my set of ordered pairs. Or if I said, give me an example of a relation in equation notation, you might say, I want x cubed plus y squared equals 4. Any equation that has an x and a y in it. The set of first coordinates in a relation is always referred to as the domain of the relation, and the set of second coordinates is called the range. Another way of saying that is that the domain consists of all the inputs, or x values, and the range is all the outputs, or the y values. If, for example, I wanted to find the domain of the relation that includes 2, 3, 4, 5, 3, -7, 1, 5, this is my relation, then my domain would be just a set containing all the x coordinates, like 2, 4, 3, and 1. Order doesn't matter. And my range would consist of all the y coordinates, which would be 3, 5, -7. I have 5 again here, but I don't need to list any of the elements twice. It's enough to list them once. 5 is in the range. That's all we need to know. So that's how we find domain and range. And now we also need to know that in algebra and business calculus and pre-calculus and calculus, if you go either of those routes, most of the relations that we'll work with are actually a special kind called a function. A function is a special type of relation in which each first component in the ordered pair corresponds to exactly one second component. Let's see if this relation that I just jotted down up here satisfies the condition for being a function. One way to check that is to list out your domain and range and draw little arrows connecting the input to the output. So for example, here we have our domain, that's 2, 4, 3, and 1. Our range was 3, 5, and -7. Looking back at the ordered pairs up here, we're going to draw arrows connecting each input to its output. So the input 2 leads to the output 3. The input 4 results in the output 5. The input 3 results in the output -7, and the input 1 also results in the output 5. Is it the case that each first component corresponds to exactly one second component? Or another way of saying that, which I think is really important to understand, is this relation a good predictor? If I tell you the input, do you know the output without any uncertainty? So for example, if I say the input is 2, you know the output's 3, right? If I say the input is 4, you know the output is 5. There's no other number it could be. There's no additional second component. If I say the input is 3, the output you know is negative 7. If I say the input is 1, the output you know is 5. Doesn't matter that the input 4 and the input 1 both matched up with one single output, because we were not told that the second components could only be matched up with a single first component. Only that the first component can only be matched up with one output. So this actually is a function. It's a good predictor. Let's look at an example from MyMathLab. So here we're asked to determine whether the relation is a function and give the domain and range. I like to start with the domain and range. So let's jot those down, right? Because then we can use that to draw our little arrows. So the domain is going to include any first coordinates or x values. There's only two, the 1 and the 2. Okay, so that's our domain. The range includes 4 and 9. These appear more than once, but we don't have to list them in our set more than once. All right, now let's draw arrows matching inputs with outputs. So the input 1 matches up with both a 4 and a 9. The input 2 matches up with both the 4 and the 9. All right, so is it the case that for each single input there's only one output? No. Right here we could have stopped and said, well, 1 matches up with 4 and 9, so that violates that. Another way of saying this is that this relation is not a good predictor. If I say the input's 1, you don't know if I'm talking about the output 4 or the output 9. So this is not a function. It's a relation, but it's not that special kind of relation that's a good predictor. Not a function. All right, let's look at this one down here. We have the same instructions, so I'm going to go ahead and list out my domain and my range and see if we have a function. So the domain includes all the x values. So we have negative 5, 5, 7, and we have negative 7. And our range, negative 2, negative 7. Remember, you don't have to put these in any particular order. Here we have 7, and we already took care of negative 7. So there we go. So now I'm going to match them up, and we're going to have negative 5 matches up with negative 2, 5 with negative 7, 7 with 7, and negative 7 with negative 7. So is this a function? What do you think? For each input, do we have exactly one output? Is it a good predictor? Yes. No matter which of these elements of the domain I mentioned, if I said the input, for example, is 5, would you have any question about what the output is? No. You would know it's negative 7. That's the only option. So this guy is a function. When you're looking at a list of ordered pairs, if you don't want to go through the process of drawing the arrows, you know you don't have a function when the same first coordinate appears twice. You do have a function if no first coordinate is repeated. And I shouldn't really maybe even say appears twice, because it would also not be a function if it appeared 3 times or 4 times. So maybe I should say same first coordinate appears more than once. It's okay for the second coordinate to appear more than once, but not for the first.
I hope you found this video useful. If you did, please remember to like it.